All right, so factoring is the opposite of distributing. So for example, if I had something like 2 times x plus 3 written like that, you may recall that in a previous math class you learned that you can multiply through that and rewrite it as 2x, 2 times x, plus 2 times 3, or 6. So when I go in that direction right there, that's called distributing. If I go the other way, that's called factoring. So if instead I started with 2x plus 6, and I notice that, hey, 2 goes into both of these numbers, I can pull the 2 out and write what's left. So factoring is like dividing. So if I were to divide this by 2, so I'm just going to write that in there, 2 divided by 2 cancels, leaving just the x. And if I were to divide that by 2, 6 divided by 2 would be 3. I would have a plus 3 there. So factoring is undistributing. It's like division, whereas distributing is multiplication. So this right here is a multiplication. And this factoring I did over here, we could call that undistributing. But it's really a fancy kind of division. Right? We do the division and then we write what we divided by out front, is what factoring is. And so we're given a couple of problems that have some numbers and variables, and we're asked to undistribute, to factor, to divide out something that is common. Sometimes it's obvious what's common, sometimes it's not. Like, check this out. Suppose we had something like 5x plus 5. Okay, the 5 seems common there, right? So then to factor this right here, I would say, all right, I see 5 as a common factor. What's left? And remember, what's left is like dividing. If I divide this by 5, I'm left with an x. And here's where people often get confused. They want to say, well, if you pull the 5 out, there's nothing left. Well, no, because factoring is dividing. 5 divided by 5 is 1. There should be a plus 1 there. Okay, so that would be the result. If you're ever unsure about your factoring, you can check by just distributing. So I can check this by taking that 5 and multiplying it through. Boom, boom. 5x plus 5. That's what I started with. Check. This is factored. Let's take a look at some of yours here. So the first two are relatively straightforward, although sometimes it's not obvious what the greatest common factor is. Sometimes it is, depends on the day. If I had a good breakfast, did I sleep well? So let's look at a couple of these. I'm going to do B, and I'm going to do C, and I'm going to leave the other two to you. So B is 8x minus 12. And some days, like if I haven't slept well, didn't have enough coffee, didn't have a good breakfast, I might look at those and say, yeah, they're both even. Okay, so I'm going to factor out a 2. 2 goes into 8 4 times. 2 goes into 12 6 times. And then I look and go, ah, they're still even. I can do it again. Okay, so I could have factored out a 4. So then I try again. All right, let's try 4 this time. 4 goes into 8 2, leaves the x, didn't mess with that. 4 goes into 12 3. Okay, now there's nothing more common. So it turns out 4 is what we call the greatest common factor. And some days I'm good at seeing those, others I'm not. The only sure way to find them, like if these were bigger numbers, is to factor each number. And I usually do what's called a factor tree. And you may or may not have to do this. Other times I just kind of use trial and error. Let's try 2. Oh, look, I could do more. So a factor tree would be to take something like 8 and say 2 goes into 8 4 times, 2 goes into 4 twice. And so if you can't divide anymore, then you're done. So that's the result of my factor tree. 8 is 2 times 2 times 2. 12, let's see, 2 goes into 12 6 times, 2 goes into 6 3 times, and so those are the factors. 12 is equal to 2 times 2 times 3. And so I can use the factor tree to figure out what the greatest common factor is by just saying, hey, what factors do you guys have in common? Well, you clearly have a 2 in common. Oh, look, you have another 2 in common, and that's it. So the greatest common factor here is 2 times 2, or 4. Okay, so if you don't like the guess and check thing, you could make a factor tree, look at the common factors, write them down, multiply them out, and that's the number you should factor out. Now, it turns out variables can be factors also. So let's look at that idea here. The next one I wanted to look at was x squared minus 5x. All right, what does x squared mean? Reminder, that means x times x. So what I have here, I could rewrite as x times x minus 5 times x. And then what do they have in common? Well, a factor is just something that's part of a multiplication. All right, well, I see an x here and I see an x there. Doesn't matter which one I pick. So that is common to both of them. So I'm going to pull out an x. What does that leave behind? Well, remember, factoring is like division. If I take x squared and I divide an x out, that leaves an x behind. And if I take a 5x and I divide an x out, x's go away, leaves just a 5. And when we do these, we want to take out as much as possible that they have in common. So if instead I had something like, how about 6x squared minus 8x? When I look at this, I say, oh, 6 and 8 are even, so I could pull a 2 out. But they both have x's in common too, so I think I can pull an x out. So I think that's my greatest common factor. And then remember, factoring is like dividing. Either imagine dividing 2x into 6x squared or write it down if you need to. So sometimes my brain needs me to write down what I'm factoring. So I might write 2x there like I did above and a 2x there and then clean it up. 2 goes into 6 3 times, so I get a 3 here. X goes into x squared x times, so I get an x there. 2 goes into 8 4 times, so I get a 4 here. X goes into x 1 time, 4 times 1 is still 4, and there's a minus. So that should be the factored version. And if, again, you're ever unsure, you can distribute to check. So I'm going to check the second one by just distributing. 2x times 3x is 6, x times x is x squared. 2x times negative 4 is negative 8x, and that is what I started with, okay? So this would be the completely factored form. All right, I want to look at one more example, and then I'm going to hang around and answer some questions, and then move on to some different problems. I'm going to skip over to the next page for a moment, because there's similar problems here. So the formula we're working with here is related to compound interest, or sorry, simple interest. We'll do compound interest later. And I want to explain what this A equals P plus PRT means. So my hope is you've seen this before in another class, and if you haven't, let's look at it now. New page. So A equals P plus PRT. Double check I copied that right. Yep. So I just want to play with this formula a little bit and explain what it means. So A here is a future amount. And we'll see how this gets to factoring in just a second. P is present amount. R is the simple interest rate as a decimal. and t is however much time has gone by. So time from present to future. Oops, present, there we go, to future. And often I want to say, okay, this is what I'm starting with. Here's the interest rate, here's the time. What am I going to have in the future? But other times I want to go backwards. I want to say, all right, I want this amount in the future. What should I do now? So what I want to try and do right here is I want to try and solve this for P. And the problem here is there's more than one P in the equation, and I can't clean up this addition here until I do the multiplication first, but I can't do the multiplication because I don't have a number for R or T yet. Here's the catch though. We can factor because these two have something in common. So what we're going to do is we're going to factor P plus PRT. Now, factoring means you see an addition or subtraction and you see something common on each side. What's common? Well, the P is common. So I believe I can factor the P out, just like I factored some other stuff. Now remember, factoring is like dividing. So that means up here, I'm imagining dividing that by P and dividing that by P. What's P divided by P? Well, a number divided by itself is 1 plus. If I take the PRT and divide by P, a number divided by itself is 1. 1 times RT is RT. So my claim is that interest formula can also be written as A equals P times 1 plus RT. The cool thing about this here is I can get rid of this multiplication if I wanted to by dividing this crazy parentheses to the other side. So we have a couple formulas right now. We have the original A equals P plus PRT. Great formula. We have a new version of that that says A equals P times parentheses 1 plus RT. And both of these formulas are designed to calculate the future value. What I really want right now is a way to calculate the present from the future. So to do that, I need to get the present value, that P variable alone. And my claim is I can do that by just dividing. So I'm going to start with my A equals P times 1 plus RT. And to break a multiplication, we divide. Since I want the P to stay there, I'm going to have to divide by that parentheses 1 plus RT. Do that the same thing on the other side. Now here I have a number divided by itself, and a number divided by itself is just 1. 1 times P, well, 1 times anything is itself, so it's just P. I did it, I got that formula. P equals A over 1 plus RT. Because my fraction's stacked, I don't really need the parentheses, I can get by without them. So I have this new formula that calculates the present given a future amount, a rate, and a time. So your goal in the next part here, finish up any of the factoring you didn't get done on page 3 here, and then use the given formula here for the first question. We're going to try it again to see if we can get a time, a formula for time, and then a formula for P. And that formula for P is the harder one, which is why I did that first. The formula for time is not that bad.